All right, let's talk about something that I know keeps researchers up at night. If you've ever designed a study, you've hit that point, that moment of panic, where you have to answer one single, incredibly important question. And honestly, it can feel like your entire project hangs in the balance. And there it is, the big one. How many people do I actually need? It seems like it should have a simple answer, right? But for so many of us, this is where the confusion and the anxiety really kicks in. So if you've ever felt that, trust me, you are not alone. In fact, the research we're digging into today calls this one of the most frequently asked questions in survey research. I mean, it pops up everywhere, in emails, on social media, at conferences. It's the question everyone has. So, what's the real answer? Well, here's the thing, and it might be a little frustrating to hear, but it's the truth. There is no single magic number. There's just no one-size-fits-all solution. And this is so, so important, because getting this wrong, it has some pretty massive consequences. Just how massive? Check this out. A major review of published studies found that around 80%, 80, of studies in top journals were probably based on samples that were too small. Think about that. The vast majority of studies might not have had enough statistical power to actually find the effects they were looking for. The stakes here are incredibly high. So, why is this so hard? Well, for a long, long time, researchers have been trying to find their way through what you could call a maze of old rules. You know, these traditional rules of thumb, they get passed down, but often end up just confusing everyone. For decades, these were the go-to. They seemed like easy shortcuts, right? A quick way to pick a number, justify it, and just get on with the actual research. The problem is, they don't really agree with each other. And just take a look at the different advice people have been given. You've got this famous table from Krejci and Morgan that gives us the so-called magic number of 384, but that only works if you can randomly sample your entire population, which almost no one can do. Then there are these ratios, like get 20 people for every question you ask. And then Roscoe's guidelines say, hey, your sample should be between 30 and 500, because anything more than 500 might be too powerful and make tiny, meaningless things look important. So which one is it? And that right there is the core of the problem. The source material puts it perfectly. With all these clashing ideas, researchers remain unclear about which one they should use. It's a maze, for sure. But here's the good news. There is a way out. This brings us to a much, much better way of thinking about this. We need to move from guesswork to justification. It's not about pulling a number out of thin air. It's about finding the right number specifically for your study. And this slide just lays it out so clearly. On the left, you've got the old way, these general, risky rules of thumb. But on the right, you have something called a power analysis. This is totally different. It's specific, it's calculated, and it's based on the unique complexity of your research. It helps you find the right size you need to actually detect a real effect if it's there. So what exactly is this power? To put it really simply, statistical power is just the probability that your study will find an effect that is actually real. Think of it like a flashlight. Is your flashlight, your study, powerful enough to actually see what's in the dark? A study with 80% power has a really good 80% chance of spotting that real effect. Okay, so how do you do this? It sounds really technical, I know, but the idea behind it is actually pretty simple. It all comes down to tailoring your sample size to your specific research model. You can think about it like you're at a control panel with 3 main dials. The first dial is significance. That's your risk of a false alarm, usually set to 5%. The second dial is power, your desired chance of finding a real effect, usually set to 80%. And the third dial is effect size. Basically, how big of a relationship are you looking for? A huge one or something more subtle? You set those 3 dials, and the power analysis tells you exactly the sample size you need. So here is the absolute most important point to take away from this. There is no magic number, because it all depends on your model. The more complicated your research is, the more pieces you're trying to connect, the bigger the sample you're going to need. Let me show you what I mean. Okay, so here's an example from a tool called G-Power. Let's say we have a simple model, just 3 things predicting an outcome. To have an 80% chance of finding a medium-sized effect, we need 77 people. Okay, that's our starting point. Now, watch this. Let's make the model just a little more complex. We'll add one new variable, a mediator, to help explain the relationship. So now we have 4 predictors. And boom, look what happens. The sample size we need immediately jumps from 77 up to 85. Okay, one more. What if we have a really complex model, a moderation model, with lots of moving parts? Now we're up to 7 predictors, and the required sample size leaps again, all the way to 103. This is the proof. The right number is always a moving target, and it depends completely on what you're trying to study. So, what's the big lesson here? It's really about a shift in how we think. The goal is not to just hit some arbitrary number. The goal is to be able to justify the number you choose. And I absolutely love this quote from the research. It says that the strength of your sample depends more on how carefully you choose people than on how many people you have. A super well-chosen sample of 150 is way, way better than a sloppy sample of 500. Quality over quantity. So, let's wrap this all up. First, stop looking for a magic number. It doesn't exist. Be really, really careful with those old rules of thumb. Instead, use a power analysis to figure out a number that's actually built for your study. And always remember, your model's complexity is what really drives the number you need. In the end, explaining why you chose your sample size is so much more important than the number itself. So the next time you're starting a project, don't just ask how many. Ask yourself this instead. What is the right justification for my sample size? Because answering that question is what leads to powerful, credible, and truly defensible research.